Okay. So, hey everyone. So, a very good evening to all of you. So, in this series of 21 days of code, today we will be discussing about greedy algorithms, right? So, I'm Sanket Singh. Currently, I'm working as a software developer at InterviewBit as well as an instructor at Scalar Academy. Previously, I have worked as a Google Summer of Code student developer for Harvard University, as well as a product engineer at Coding Blocks. I have also interned at Indian Space Research Organization and worked with few startups like Cacto Fashions, Fable HQ, so on and so forth. Right. So today we'll be discussing two problems on greedy algorithms. So let's just start. Okay. So let me just share my screen to everyone. Right. Okay. So the first problem that we are going to discuss today is the problem highest product. So what the problem says is that given an array A of n integers, return the highest product possible by multiplying three numbers from the array. So what is the input format? The input format says that the first and the only argument will be the integer array that will be given to us. What should be the output format? In the output format, we are supposed to return the highest possible product, right? And the given constraints are like these. So let's say that the given input is like 1 comma 2 comma 3 comma 4. So the product of the highest product extracted by multiplying three numbers will be equals to 24. This can be extracted by using 2 into 3 into 4, right? Whereas let's say the input is 0 comma minus 1 comma 3 comma 100 comma 70 comma 50. So the output will be 35 into 10 raised to power 4. How? You can extract these three numbers and the product of these three numbers are going to be highest, right? Okay. So let's just see that how we can solve the problem. So basically, the problem asks you that given an array, extract any three integers such that their product is the highest, right? Okay. So let's say that you have an array like a1, a2, a3, so on and so forth till an, and the length of the array is n, right? So in order to extract the three integers such that their product is highest, what we can do is, as this can be an unsorted array, what we can do is we can just extract three highest valued numbers, right? And take a product. So similarly, as given in our example, where we were given the things as 1 comma 2 comma 3 comma 4, here you can see that 2 comma 3 comma 4 will be giving you the highest product, as well as these three numbers are of the highest value possible in the given array. So what we are supposed to do, we can just extract the three highest valued numbers and take a product. But wait, only the highest valued numbers cannot be considered as the only candidate to get the highest product. Let's say that we had an array like minus 70, comma minus 1, comma 3, comma 4, comma 5. So inside this array, if you will just extract the highest valued number, so this will be 3 into 4 into 5. Whereas there is one more candidate that can become the highest product using three numbers, that is minus 70 into minus 1 into 5, that is plus 5. And among these two, here you can see that this will give you the better answer or the higher value answer. Now, why this is coming as? Because we need to have the product for three integers. And among these three integers, if two of them are negative and one is positive, then also we will be getting a positive product, right? Whereas if all three are positive, then also we'll be getting a positive product, right? But let's say two are positive and one is negative, then the product will be negative, right? So what we can say here is that just comparing the highest valued numbers in the positive side won't be enough. What we need to do, we need to find the two minimum most element as well, and the product of these two minimum most element with the highest value number can also give you one more candidate, and among these two, one of the following will be your answer. Now the problem boils down to the fact that given an n length array, what we are supposed to do, we are supposed to find the three maximum value numbers as well as two minimum value numbers, right? Okay. So as you can see that in order to extract the three highest valued numbers, what we can do, we can just, in brute force sense, if we just apply a brute force approach, what we can do, we can just sort the array. We can just sort the array. And after sorting the array, what we can say is, let's say after sorting the array becomes as b1, b2, b3 till bn, right? And let's say that this is the sorted sequence, that is b1 is less than b2, which is less than b3, so on and so forth till bn, right? So if this is the case, then what we can say here is the last three indexes will be giving you the highest valued numbers, right? Whereas the first two indexes will be giving you the two main value integers, right? And using these, we can generate our two candidates and just multiply them to get the final answer. But to sort an n length array, what we'll be doing? We'll be doing an n log n kind of a approach, which will lead to the complexity as big of n log n, right? Okay. So the big question is, can we optimize? Can we optimize further than n log n? Anyone who wants to have an approach can just send me your approach in the chat section, right? So let's say that if we do not want to do sorting, then what we can do is we can manually extract the three largest integers and two smallest ones, right? Now, in order to do so, what we can do, we can have one iteration that will extract the maximum, second iteration to extract the second maximum, third iteration to extract the third maximum, then fourth iteration for extracting the minimum, and the fifth iteration to extract the second minimum. Using these 5 separate loops, we can extract the corresponding candidates. But here you can see that we are reading our array more than once. Let's just see that if we can devise an approach so that we can just do it in single pass as well. That is, we can just read the array once and we can extract our answer. Okay. So let's say that the input is like -70, -1. It is -70, -1, then 2, 4, 5, 6. This is the given input. Okay. Now we need to, so already in a sorted sequence, this is already a sorted sequence. Let's just rearrange it to make an unsorted sequence. So let's say it is 5, 6, -70, -1, 2, 4. Right. Now this is a perfect unsorted sequence. Now what we need to find is, we need to find the three largest integers, right? We need to find the three largest integers. Now what we can say is that in the first subarray, this is the first subarray of size 3. In the first subarray of size 3, we will be having 3 candidates, right? And these 3 candidates will be our 3 largest integers till now. Till now, when we have not read any other elements in our corresponding array. Now, as soon as we will read a new element, let's say I read -1. Now, as we have now here -1, and we can just have 3 largest integers, what we can say is, now we have accumulated one more element, but this element makes the size as 4 for the corresponding subarray. So what we need to do, we need to replace this corresponding number -1. We need to replace this -1 with the smallest number in previous set, right? We need to replace this with the smallest number in previous set. Why? Because if we just extract out minus 70 from our context, then from this index 0 till this index 3, we will be having 5, 6, minus 1 as the three largest numbers, right? Then we'll be having 2. So to include 2, we just need to replace the 2 with the smallest number from the previous set. So here you can see smallest number from previous set was what? Minus 1. So we'll replace it, and here you can see that in this corresponding subarray, we have extracted our corresponding three largest integers. Now here you can see that whenever a new number has been added, we need to find the smallest number from the previous set. Now the problem boils down to the fact that given a set of numbers, we need to find the smallest among them and need to replace our new element with the smallest one. If this element is not even smaller than the smallest one, obviously, right? So how we can do this? So what we know is we have a data structure called as priority queue, right? Or we can say heaps that can do the task. How? Heaps can be used to extract the minimum most element or the maximum most element from a given set of data. Yes or no? So what we can do here is we can maintain a min heap of size 3. We can maintain a min heap of size 3, right? And we can just add the initial 3 numbers in our min heap, right? We can just add initial 3 numbers in our min heap. So our min heap will be looking like minus 70, then it can have 5, then it can have 6, right? This is the min heap. Now, as soon as I'll just hit minus 1, what we'll do? We'll just insert minus 1 in our heap, right? After inserting minus 1, what we can do? We can just delete the minimum most element. So the minimum most element was minus 70. So it will be deleted and minus 1 will come here. Minus 1 will come here. So here you can see that after inculcating minus 1, in O1 time, so in O1 time, we are able to just delete minus 70 and add minus 1. Now you guys will say that how it is O1? Because a deletion operation in heap requires log n time. But here we have a constraint that the min heap can be of at max size equals to 3, right? So in a size 3 heap, what we know is the deletion will be very much in a constant time. So it won't be taking a lot of time. So we can just consider it as O1. Now similarly, as we have just extracted, so Goel is saying, right, that k largest element of array using minimum priority queue. Yes, we are doing something similar to that. Yeah. So Ravi is also saying, right, Ravi Kumar is also saying, right. So what we know is if we are able to extract the largest number using min heaps, because every time we just need to discard the minimum most element, what we can say is if we need to find the 2 smallest element, then according to you guys, what will be a very good data structure that can find me 2 smallest element as well? Let's see what we are trying to say. Initially, the subarray will be 5, 6, so these will be the smallest ones. Now the subarray will increase to minus 70. Now minus 70 should be replaced with the largest element. So minus 6 should be replaced and minus 70 should be added. Now after adding minus 1 should be added and largest number should be deleted, so on and so forth. So again, what we can do, we can take a max heap of size 2 and then just calculate the 2 minimum elements as well. And along with this procedure, when we will be just reading our array, I'll just take a max element kind of a variable that can just store the maximum element from the whole array. And after extracting these, our candidate 1 will be max element into 2 minimum element product, and the candidate 2 will be equals to the 3 maximum element product, right? And we will return the maximum among these. We will just return a maximum among these. So how many of you guys are able to understood the problem? Ping me a yes or no so that we can just proceed, right? So we can just start coding the solution. As we have understood the corresponding logic, we can just start coding the solution. So here you can see that I have opened the problem on the InterviewBit platform. So the link for the problem is introbit.com/problem/highest product. So let me just log into my account, and then maybe we can just start the coding part, right? So just a second. Okay. Maybe we can just reset this. Yeah. Okay. Okay. So here you can see that we will be getting an input of the vector as a, and we need to return an integer variable, right? So initially what we will do, we will just initialize a priority queue, right? This priority queue will be storing integers, right? And we know that by default the priority queue of C++, as I'm coding in C++, the by default priority queue of C++ is a max heap. So here we will just initialize a priority queue mx. Then what we can do, we can just initialize one more priority queue, that will be the min heap. And to initialize that kind of a priority queue, what we need to do, we need to pass a vector of integer as well as the greater comparator, right? So this will help us to initialize the corresponding priority queue to the min heap, right? So as we can see that we have initialized both of them. Now we will keep a variable n that will be storing a dot size. We can keep one more variable max element that will be initialized by int min, that is minus infinity, so that we can also extract the maximum element from that. Now there is one more corner case I got out, that what if we have 0, right? If we have 0, then we need to handle the cases specifically. So we will see that how we can handle the cases, right? So what we can do is, so for int I is equals to 0, I less than n, I plus plus, we will go to all the corresponding elements, right? Apart from that, we will maintain a Boolean variable has 0. This will help us later in our algorithm. Initially, we will just initialize it as false. And at any point of time, if a at I is double equals to 0, what we need to do, if the current element is 0, we can't add it directly in our minimum set or the maximum set, because it will just nullify the product to 0. We need to handle it differently. So we'll just continue and mark the has 0 variable as true. You will see that how I'm going to handle the corresponding this one, right? So as soon as we have handled the case for 0, now we know that the min heap that we are going to do, it should be at max of size 3. So what we can say is, if mn dot size is less than 3, if it is less than 3, then what we can do, we can just directly push array at I. We can just directly push array at I. And if this is not the case, then what we can do, we can just push one element inside our min heap, and we can just pop out one element. So mn dot pop, right? We can just pop out one element. Similar thing can be done for the max heap, apart from the fact that we need to have the size at max as 2. So we'll just insert the things as it is in the max heap if the size is less than 2. Otherwise, what we are going to do, we can just push an element, and as soon as we have got 3 elements, we will pop one. Apart from this, we have also a max element variable that is going to keep a track for the maximum variable. So if max element is lesser than the current element, so what we are going to do, we will store the current element, otherwise we will store the max element, right? So after completion of this loop, what will happen is, we will be having our max heap ready, that is containing the 2 minimum most elements. And after this loop, we will be having our min heap ready as well, that will be considering the 3 largest elements. Now what we are required to, we just required to multiply all of these, right? So in order to multiply these, let me just share the screen again. So what we can have is, we can have 2 candidates, int candidate 1, that will be initialized by 1, as well as int candidate 2, that will also be initialized by 1. Now what we can do is, while not mn dot empty, while mn is not becoming empty, what we can do is, candidate 1 can be multiplied by mn dot top, right? And we can just pop out the element. So this loop will help us to get the product of all the 3 largest numbers. Then we can do similar thing. We can just do similar thing for the two maximum elements with candidate 2, right? This will be mx and this will be mx as well, right? And at last, candidate 2 will be multiplied by max element as well. We'll be having int result variable that will be storing the maximum of candidate 1 comma candidate 2, right? Now here comes the significance of hash zip. So there can be a case that both the candidates that were extracted by having the three largest element except 0 and one largest and two minimum element except 0, their product becomes lesser than 0, but we still have 1 0 in our array. So what we need to check is, if we have a 0 in our array, if hash 0 is true, then result will be equals to maximum of result comma 0, right? After that, we can just directly return result, because if we will not be having 0 inside our array, this check won't be executed and we will just directly return the maximum of candidate 1 and candidate 2. So let's just test the solution once if we are not having any compile time issues or something, right? Okay, so there are some compile time issue. Let me just check and see. Okay, so there is a comma missing here. So most probably the issue was with the comma. Okay, and there is one more issue. We need to have a equals to here. Okay, yeah. So the sample test case has been passed. Let's just submit our solution, right? Let's just submit it. Okay, yeah. So here you can see that it is successfully submitted and we have got the correct answer. So I hope the logic for this problem is clear to everyone. If anyone is having any doubt, you guys can ask me, right? So Alok is asking, sir, why max element variable is used? So Alok, I'm just extracting the max element so that I don't need to reiterate on the priority queue that is having the maximum elements, right? So I'm just separately having one maximum element variable, because this maximum element will be multiplied by the two minimum element that are stored in the heap, right? Guys, is the logic for the problem clear to everyone? Shall we move forward? Shall we move forward? So Goyal, let's say that let me just draw one test case. I guess after that you will be able to understand it better. So let's say the test case is like -7, -6, -5, -4, -3, -2, 0. Right? Okay. Now in our code, what we have written is, we have just continued our loop. Whenever we are extracting, whenever we are encountering a 0, we are not considering the 0 inside our priority queue. So finally, our priority queue will be storing these three as the maximum variable, these two as the minimum variable. And here you can see that the product of these three will be what? This will be 12 to 24. This will be -24. And the product of these two along with -4, along with, just a second. Yeah, so the product of these three along with the maximum element of this one will also be something negative, right? But we have a 0 here, and if we would have inculcated 0 with any two more elements, then the product would have been better, right? So that's why we have separately handled the case for 0. Is this clear, Goel? Goel, is this clear? Is the logic clear? Okay. Maybe if you guys have any more doubt, then you can just ask me in the chat section, right? Okay, so let's just move forward to the next problem. So the next problem is also from our platform, that is the problem bulbs. So what the problem says is that given n light bulbs that are connected by a wire, each bulb has a switch associated with it. However, due to faulty wiring, a switch also changes the state of all the bulbs to the right of the current bulb. Given an initial state of bulbs, find the minimum number of switches you have to press to turn on all the bulbs. You can press the same switch multiple times. And the notice given here is that 0 represents the bulb which is off and 1 represents the bulb which is on, right? So let's say the input format. So input format says that we'll be getting an array of size n, right? So here you can see this is the array. And if let's say the array is equals to 1 only, then obviously we are having only one element. So no need to just turn on any switch. So we need 0 flips. If we have an array 0, 1, 0, 1, then what we can do, if we just press the switch 0, which is at this position, then all the rest of the switches will be flipped. So here you can see this becomes 1 and rest of them are flipped. So 0, 1, 0. Now we will be pressing the switch at index 1. If we just switch the element at index 1, it will become 1 and these two will be flipped to 0, 1, so on and so forth. So in this case, to turn on all the bulbs, we will be requiring 4 flips in the whole array, right? So I hope the problem is clear to everyone, right? The problem is clear to everyone. So maybe you guys can think for some solution for the corresponding problem. Any solution that you guys are able to think of? Anyone? Okay. So let me just give you a hint. Let me just give you a hint on this problem. That is, if let's say that you have flipped any bulb at an index I, do you guys think that there is any need to flip the bulbs to the left of it? Because any bulb at an index I is going to affect all the bulbs at the right side of it. That is from I plus 1 to the index n. So maybe this can be considered as an hint, and maybe you guys can think of something in this direction, right? Okay. So let's just discuss the solution, that how we can proceed for the corresponding solution, right? Okay. So let's say the given array was 0, 1, 0, 1, right? Okay. Now what we can say here, is for any bulb AI, right? What we know is that if let's say there can be two states, that this bulb can be initially off or on, right? These two can be the only states for the bulb, right? So what we know is, if for the bulbs that were present at the left of it, if at the left of it we have some bulbs and they are also able to change the state of this bulb, then when we will be just encountering this bulb, it can be at on position or it can be at off position. Can we predetermine what will be the state of the bulb, right? So let's say that we have bulbs like A1, A2, A3, A4, so on and so forth till AK, so on and so forth till AN, right? So let's say that you are considering this bulb A of K. Now for this particular bulb, what we can say is, if before this bulb we made X flips, and X was even, that is the number of flips that were made before encountering A of K. If these flips are even, can we determine something, right? So if the bulb's original state was, let's say, on, right, and this X number of flips is even, if the number of flips is even, then what we can say is the bulb's original state is on and this is even, then there can be a issue like, let's say the state was 1 and we had 4 flips. So due to the first flip, this would have been changed to 0. Then due to the second flip, this will again be changed to 1. Then due to third flip, this will again be changed to 0. And due to the fourth flip, it will be again changed to 1. So here you can see initially we were 1 and finally we are also 1, right? Let's say that the value of X was odd. So instead of 4, let's say we have 5 flips. So we'll be doing one more flip and the value has been changed. So what we can do is, similarly, what we did for the on state, we can do the same for the off state as well. So while encountering any bulb, if we are going to flip it, we will just maintain a count that how many flips we have done. Now, the problem boils down to the fact that we need to make a decision that whether we should flip an off bulb or not? So the answer would be yes. Any off bulb that you are going to encounter, we should definitely flip it. Why? Because this is never going to harm. This flip is never going to harm to any bulb to the left of it. Whereas it can definitely make some bulbs to the right of it in the state on, from the state off. From the state off, it can just convert them to on. So greedily, what we can say is the local optimization that we have done, that is at any local level, if we had made a decision, this is obviously going to make a contribution in our final answer, right? So what we can do is we can just iterate over all the bulbs. If the state of bulb is off, we will turn it on, right? Now, here we can say that one solution can be what? If we are just going to update any bulb, we can just iterate over the right side of the bulb and just flip all the values. But this solution will take big O of n square time. Why? Because for each element, we are going to traverse the right side of the array completely. But few minutes back, we just saw that if we know that in originally what was the value of the bulb, that is it was on or off, and how many flips we have done till now, we can just predict the value that whether the bulb is currently off or not. And based on this fact only, we are going to code our solution, right? So using this approach, the time complexity required will be big O of n only, because we are just traversing all the elements once and just maintaining a count along with them, right? So let's just see that how we can code the solution, right? Yeah, Bake, you can use that. You can use that. One solution can be using that as well. Don't worry. Okay, so this problem is also on the InterviewBit platform. So the link for the problem is interviewbit.com/problem/bulb, right? So let me just start the solution. So here you can see that we will be having a vector A, right? So what we can do, we can have a counter variable that will be keeping a count of whether we have made even number of switches or odd number of switches till now, right? We can have int n is equals to a dot size, right? After having n, what we need to do, we need to just iterate over all the elements, right? So we can also make a result variable. Right? This result will be storing all the numbers, all the flips that we have made, and at last we will just return this result only. So now what we need to do, we need to just iterate over all the elements. Int I is equals to 0, I less than n, I plus plus, right? And then what we need to do is, if the current element, that is array at I, was double equals to 1, that is, we know that the state 1 represent the bulb is on. So if the current bulb is on and count is even, that is count mod 2 is double equal to 0, we don't need to do anything because it is already in its on state, right? So the original state was also on, and after having even number of flips, the final state will also be on. So we will just continue, right? Else if array at I is double equals to 0 and count mod 2 is not equal to 0, that is count is odd, right? So what we can say is, after having odd number of flips, the ith index bulb will also be the state of the ith index bulb will be changed, and from 0 it would have been become equal to 1. So again, we don't need to do anything because it is already on. So we'll just continue. Else if the current value of the bulb is equals to on and count mod 2 is not equal to 0, that is count is an odd number, then obviously this state would have been changed and now it is off. So what we need to do, we need to make one flip. So result will be incremented, result plus equal to 1, and counter will also be incremented. So this will be counter everywhere. So this is counter, and the counter will be incremented to 1, right? Similarly, if the original state of the bulb was equals to let's say off, and the counter is even, that is counter mod 2 double equal to 0, then also we need to flip it again. So result plus equal to 1 and counter plus equal to 1, right? And at last, what we will do, we will just return the result. So let's just run the corresponding solution and see that if we have passed all the cases or not. So the sample input has been passed. So let's just submit it. And here you can see that we have finally submitted the solution, right? So I hope the logic for this problem is also clear to everyone, right? So, so one student is asking that how to identify that if the current problem is going to be a greedy problem or not. So what you need to ensure is, if at any particular state, if your local choice that you are making is independent of the fact that what choices you are going to make later in your solution, then you can definitely go towards greedy, right? Because the local optimization that you have done will definitely add itself to the global optimization. So this is the thing that you need to ensure in every answer. As in this answer, we saw that if you will just flip one bulb at any point of time, it is not going to hamper any bulb that we have flipped previous in time, right? And also, if you will flip it at this point of time, then only it is going to just turn on some off bulbs. So it will automatically reduce the number of flips if we will just flip it at this particular number at this particular position, right? So this is how you can just explore that how greedy algorithms work, right? So any more doubts from anyone? Okay, so I'll be just posting the link of both the problems in the comment section, right? And yeah. Okay, so Alok is asking one very good question that cannot we simply print the counter as our answer? So in my solution, I have repetitively incremented the value of counter. What you can do, you can just take a Boolean variable and just treat it as a flag and keep your result variable differently. Otherwise, you can use both the counter and result variable simultaneously. You are not bound to make them differently, but this was my own implementation, right? Okay. So, guys, the link for the problem for link for the both of the problems have been posted in the comment section. Do check them out and continue your streak on 21 days of code. So this was all from my side. This was Sanket Singh. It was an awesome experience to have a discussion on two problems of greedy algorithm with you guys. So we will meet in our next lecture. Thank you.